Welcome to the second part of our two-part lecture on oil. In the previous part, we kind of talked about some of the background of oil. We talked about oil production and a lot of terms associated with oil, the history of oil, history of OPEC. Now we're going to talk about how we get oil, how we find it, and how we get it out of the ground. We're going to start out with what I would call an anti-depletionist guide. In the world of oil, you have, if we were to boil it down, of course there's a lot of gray area, but if you were to boil it down, you have the sky is falling, and then you have the sky is the limit. The anti-depletionists would be on the sky as the limit. And the anti-depletionists will say, we'll never run out of oil because there's always going to be new technology. We can always drill deeper, not so much deeper into the ground, but we can drill deeper in the ocean. We can go in deeper in oceans because of technology. I should even say there we can drill horizontally and we can use different drill types. You can always drill someplace else and you can always speed up your exploration efforts. Now there's truth in all these, but then there's also limitations to these. If we look at more of a practical guide to finding oil, and this would be Petroleum Geology 025, very, very rudimentary. So once again, if you're listening to this lecture, and feel free to post comments on YouTube, but keep in mind this is an intro lecture and it's meant as an overview. Oil is found in reservoirs underground, and you need some type of a cap rock to hold the oil in, otherwise these hydrocarbons would literally leak out of the ground. So you need the right geologic structure, you need the right depth, you need all these right situations for this to occur. Oil will be found between about 7,500 and 15,000 feet beneath the ground. Why? Well, if you get much higher above that, you don't really have enough pressure to crack down the hydrocarbons, and you get more like that tar sand sludge, or you get this gooey stuff. It just doesn't work out that well. When you start getting below 15,000 feet, you have so much pressure that the hydrocarbons have cracked apart so much that you're starting to get into turning these things into gases. So your window for oil is about between 7,500 and 15,000 feet beneath the surface. Oil likes to be found in what are known as structural domes. These are where the big deposits of oil are. You're not really going to have any of these discoveries anymore because this is where the oil was first discovered, and this is, in terms of yield per effort, this is where you have a lot of oil, and lots of times it's very easy to take out because it's kind of under pressure and it'll come out on its own accord. Salt domes, they have that nice big dome of salt covering it, and then you get underneath the salt and it's all there. Avery Island is an example of a salt dome down in our Gulf of Mexico. You can also find an anticlinal and synclinal traps. These are called stratigraphic traps. This is kind of little pockets where the stuff is found. And where do you find this stuff? Well, in terms of conventional oil, it's found in what's known as porous reef rock. Petroleum geologist is going to love a very, very porous limestone. Why? Because the oil will flow through it nicely to get to your production well, and it's going to be able to hold a lot of it. There's a lot of rock out there that up until we've had hydrofracturing techniques and these detergents to help break down the oil, a lot of the rock out there, it was in there, and these geologists would find the oil and they would know it's there, and there's high amounts, but there's just no way to get out of the ground. In fact, the petroleum geologists would call that suitcase rock. And the reason why is because you would have to pack up your suitcase and go home. It's kind of an outdated term because now they're looking at this stuff in computers and office buildings in Houston, and it's all geographic information system type exploration. Well, I shouldn't say all, but it's very advanced compared to back in the days when you would pack up your suitcase and go home with suitcase rock. But by far, porous limestone, very, very oolitic limestone would be, a petroleum geologist would be drooling over it. So how to drill for oil? Well, you have primary recovery and then you have enhanced recovery. Primary recovery is to where you put in your exploration wells, you know that there's oil down there, and so then you would put in your production well. And your production well is to where the oil is pretty much going in, and sometimes it's shooting on the ground on its own accord. It's that positive matrix potential you talked about in water, to where it's gushing out. You don't even have to pump it out. Well, a lot of the oil wells that we have in production now are actually engaged in what's known as enhanced recovery or tertiary secondary recovery. And this is where you're going in and you're putting in these wells and you're going back to where you were formerly getting oil out, but you got to push the oil through. And so you can inject CO2 in the ground, and that CO2 is going to push the oil through that layer where it's found and into your production well. So you're kind of going back and you're using a different, more advanced technology to do that. In some wells, you can inject steam into the ground. Detergents are often used within the steam to help make the oil less viscous or less gooey and thick. This is a common method now. You'll see how here we have shale. So you have your oil shales. Of course, you have your fracturing technique to create the rocks in there, or the cracks in the rock. But then you're injecting the steam in this detergent. You're breaking it down. It's kind of like when you take Simple Green and you put it on a bike chain, and it makes all that gooey oil all over your bike chain just come off nicely. Simple Green is really great for breaking down oils. That would be your detergent. And then, of course, you take the detergents out and your oil is usable. Now, fire, not very common and not very safe. We'll move on from that. Very efficient method is miscible gases. This is kind of expensive. It's not often used, but it's the most efficient. And then, of course, you have carbon dioxide, which is the most common method of taking the oil and pushing it through in terms of enhanced recovery. Let's move on. Now, I want to bring up something called ANWR. What about ANWR? Because ANWR is the Arctic National Wild Refuge, and I'm bringing this up because it relates to our domestic production. This is very much related to 2008 election when you heard the expression drill baby drill. And drill baby drill, it reflects a lot of people's emotions at the time because of the high gas prices. But the drill baby drill debate really, both sides of the aisle, the environmental side, or I would say the anti-drilling and the pro-drilling, kind of were they're both were kind of missing the mark on it in different ways. Now, I'm gonna provide you an objective view on this in terms of domestic oil production. One area of domestic oil production that they wanted to put in was this north slope of Alaska in the Arctic National Wildlife Refuge. And the idea was to open it up for drilling, and if we open this up to drilling, then the price of oil would go down and we would get rid of our imports. The issue with that, though, is that, well, the environmental footprint for something like this really isn't that big, especially when you're with proper oversight and regulation. If done in the wintertime, you have a very minimal footprint. The issue is, why would you put all that money into developing that infrastructure in something that is so far removed when we have all these different areas that could be put into production anyhow? And so we have to remember that we're a mature oil province in terms of conventional oil production. Now, this is where you would have your conventional oil wells put in. It's not really known how much is in there, but some of the best case scenario is that this would account for less than 2% of all of our oil in our ground reserves or reserve oil deposits, to where we have it to where we don't really know how much, but we're saying, well, we have oil here and here and here. And a lot of that is being drilled right now, in fact. If we look at this in terms of the best case scenario, if we were to, back in 2008, start just going gangbusters and developing and putting all the infrastructure in to get this over get the materials that are here all the way over to here to the Alaskan pipeline. It would take about, it takes about 10 years to get these things online, and that's going at a very rapid rate. We would go from 9.5 billion barrels today that we produce to 10.1. That would mean that in 2020, we would go from 70% to 68% of our oil imported. Now, what's really interesting with the debate on this and why you don't really hear the drill baby drill with this anymore, except for some fairly extreme ends of the spectrum, is it's really a non-entity now with our non-conventional oil production that's going on in areas like North Dakota and Wyoming, to where all over in the Great Plains, I should say, is that with these new techniques and technologies that we have, we're really off, and of course, hopefully diversifying our energy economy, energy sources. You don't really need this, and this would be me weighing in my opinion. I would say, oh yeah, eventually this would be a great place to drill for oil, but let's drill for that oil to supply the plastics and lubricants within our other energy sectors, such as wind and solar. But once again, that's my opinion. I'm sure I'm going to hear about it. Moving on. Here goes a graph showing that, and this is just a graph showing you how developing something like ANWR really is, and I have a link to a website for this, but it's really not that stellar in terms of what would come out of that. So let's move on again. Instead of splitting this lecture up, I think this would be a good time to pause it, get yourself a beverage, whatnot. But from here, we're moving on from talking about how scientists get the oil out of the ground, we're going to talk about how do you predict the future of oil production. So this gets into more of economists, statisticians. I'm going to ask you this question. Which of the following is not useful to predict future oil production? If you answered this, you are correct. Why? Because oil-producing countries, especially within OPEC, are not very honest. They missed that day of kindergarten, or whatever you want to say, in terms of you shouldn't lie, because the world of oil, there's a lot of, let's just put it politely and say there's a lot of fibbing going on. Why can I say that? Well, let's take a look at this graph. In this graph, if you answered D, you are correct. In this graph, you can see that pretty much overnight, Saudi Arabia went from 400 billion barrels of oil in their estimated reserves to 600. And then once again, in early 1990, they jumped up to 700. That wouldn't be too amazing, except for, lo and behold, all these other countries pretty much did the same thing. So did all these countries come across this new form of technology that allowed them to discover all of this new oil at once? Or could it be that somebody like Saudi Arabia did that because they increased their production, but they didn't want to lose money in increasing their production, so they just said they had more? Why is that? Well, in the world of oil, it's not as if it's not like maple syrup, to where you have maple syrup being sold by the gallon, and every gallon you sell is what you get. In the world of oil, there's so much flowing that you can't really measure it in that way. So the way it works is that based on your holdings of oil is how much of percentage of the pie you get of money in sales. So if you're Saudi Arabia and you have 25% of the world's oil, you're going to get a much bigger percentage of the oil revenue than countries that don't have that. And so the more oil you have in your reserves, the more oil you get. And this is what you see here, is you see Saudi Arabia doing that and all these countries reporting the same, so they didn't lose that cut of the pie. This is why when we start looking at how much oil is left in the world and how much oil is out there, you can't really go on what countries, and to a certain extent what even our own oil companies are reporting. You got to use some pretty creative statistics. So how do you do that? Well, you tally the oil produced to date. You estimate what's in reserves. Now, I'm saying estimate by looking predominantly at oil in existing production fields. And then you can also estimate how much oil is left to be discovered. When we look at oil proven reserves, this is how much is proven out there. What you can see is that Saudi Arabia definitely does have the majority of the world's oil. Relating to when we were talking about Gulf War I, you can see why the United States, Great Britain, and other countries of the world, and Saudi Arabia for that matter, were pretty freaked out when Iraq, with a fairly substantial amount of oil themselves, invaded Kuwait, bringing them close to what Saudi Arabia has. And if they were to take in Saudi Arabia, that is a huge chunk of the pie that they are controlling, and therefore controlling a lot of the price. And when you have a dictator, well, he's no longer with us, but that would have not, it wouldn't have been very funny. There are 98 oil producing countries in the world, but of those, 64 have passed their production peak and 60 are in terminal production decline. That means that there's really no new fields getting discovered, and the ones that are there are in terminal decline. They're past their peak, they're eventually going to play out. That's conventional. And that's where it's interesting, is because now with all these new non-conventional methods, these numbers are very different, and I hesitate to even post them because nobody really even knows. It's not as if there are these huge wells out there. It's multiple small little stratigraphic traps that are being drilled and produced by kind of a smaller group of entrepreneurs. It's a very interesting age of oil production. Here we have a graph for OPEC and non-OPEC countries. You can see that Saudi Arabia, Iraq, Iran are the leaders. If you look over here, you can see Venezuela is clearly the leader in the Western Hemisphere, and they're the only one within OPEC. You see Europe, Asia, and Australia, with Indonesia as a member of OPEC. Russia is kind of unique in that it's not a member of OPEC, but it's the largest producer. And of course, they produce the most natural gas as well. You see over here, Africa, you have OPEC countries that are the leaders in oil production. So when will we run out of oil? You take a look at this graph and you are going to say, wow, in 2040, we're just going to run out overnight. No, that's not going to happen. You're not going to wake up one morning and there's not going to be any oil left. The more likely scenario is going to be, let's use this pen, is something more like this. And then you might have a decline like that over a long period of time. Reason why is because eventually production is not going to be able to meet demand, but you're going to see the price get so prohibitively expensive that people are just going to stop using it as a resource and start using something else. What is being done right now in the United States and other areas of the world in terms of looking at diversifying our energy is the thought that, hey, we don't want to have it to where we need to have a rough transition because the price gets so high that we're hurting our economy. You want to have that gentle transition from one energy to the other. And that's why a lot of people are saying that natural gas is going to be a great bridge fuel for us to go from one energy economy to another. If I were to weigh in with my opinion on this, my worry is that natural gas, instead of serving as a bridge fuel, is going to instead kind of serve as, oh, well, we're done with oil, now we can use natural gas, and then not move into looking at diversifying our energy economy beyond that. When we look at conventional oil production, though, when we look at this in terms of when it did peak, a lot of analysts say it did peak around this period right here. Let's actually go back into my arrow. Now that's conventional. What's going to be very interesting in the upcoming years is seeing what's going on with non-conventional oil production, and for that matter, what's going to happen if natural gas does start to overtake within our transportation sector and within other sectors of the economy, such as even electrical energy production, what happens then? What happens if Japan starts successfully extracting methane hydrate? We we don't really know when peak oil production will ever occur. We can say that conventional did, but let's just see what the future holds. There is no crystal ball in this stuff. But when we look at this in terms of conventional, we can look at these factors. Now, I'm not going to get into this too much because this is a Scientific American article that I have posted on your readings that's going to get into this in more detail. And that's conventional oil production. Here goes another graph from there. And what's interesting with this graph, though, is that 80% of the oil today comes from fields discovered prior to 1973. Take a look at this in terms of oil production predictions in terms of peaks, but then this is going to be interesting how it plays out in upcoming years when all these non-conventional oil fields come online. What's going to happen with that statistic? And why are these projections now somewhat inaccurate? Because it's like I've been stressing throughout this lecture, you have conventional versus non-conventional oil production. Non-conventional, you have your horizontal drilling, you have your hydrofracturing, you have your use of detergents, you have your tar sands, you have your oil shales. These are all changing the equation of how much oil is being produced and where it's coming from. And it gets back into when we were talking about resources back in that first lecture, what makes a resource? What makes one resource, what makes something a resource suddenly that wasn't a resource before? Well, all of a sudden you have the technology to use it, or in this case, the technology to extract it. You have different technologies of taking that oil out of the ground. You have hydrofracturing, you have horizontal drilling. You also have, now with the cost of that resource getting high, what's going to happen now in terms of the demand for oil? Are we going to start seeing a demand for other products? We already saw that with oil in terms of electrical energy production, where oil is not really used to make electrical energy anymore because it's too expensive to do that. We might see that in our transportation sector to where eventually oil is going to become so expensive it's no longer going to be coveted, and technology is going to get developed that makes natural gas or potentially electric cars something that is economically feasible to use, and oil will just kind of go on the wayside and just be used for plastics and whatnot. Diversity of demand. The more diversity you have in an energy economy, the less demand you're going to have on that one commodity of oil. I encourage everyone who's listening to this lecture to read a book called The Quest by Daniel Yergin. It's a very objective-based view, and it's very comprehensive by looking at all sorts of different energy. He also has a book just dealing with oil, but I found it remarkable how well he tied oil into the rest of our energy economy. Great book. And finally, before we end, I have some other recommended reading, but I also want you to take a look at this, because these two paragraphs pretty much reflect my sentiments on it. So if I were to end with my own little thought, I would say before you start getting into these different political and ideological camps with oil, be informed. Get informed, look at some non-biased, objective information, and establish how you feel about how oil relates to our energy economy and how to deal with that situation. That's it.